Right. See, we are going to discuss about the first one is a time complexity. So first thing is, so what is a time complexity and so why we need to learn? It's very simple. Time complexity is always used to analyze an algorithm. Use it to analyze an algorithm. That is, so normally, what is the purpose of algorithm? Algorithm Algorithm is a step-by-step process to solving a problem. To solving a problem. But here, that algorithm is an efficient algorithm or not. Efficient algorithm to solve the problem or not. That we can understand with the help of time complexity only. Just to solve the problems, they proposed the algorithms. For example, a simple example, searching techniques and like a sorting techniques. Searching technique means what? Is to search for an element in an array or any location. Sort means what? Is arrange the elements either in ascending order or descending order. Different types of searching algorithms given and different types of sorting algorithms given. Here it is. So what is the efficient algorithm? What is the efficient algorithm among all the available algorithms? That is only what? Finding that because of time complexity only, with the help of time complexity only, we can find out which is that efficient algorithm. That is. Now here, using some of the examples, first of all, we need to identify uh, how much time, how much means what is the constant time it is taking to produce the solution for the particular code. For the particular code. For example, if you are executing only a one line of code, let us take x is equal to y plus z. X equal to y plus z. Any single instruction, suppose calling the function. Calling the function. It is a constant time it will take. Is a constant time it will take. So that is what is O of 1. It's a constant time. This order of 1. Order of 1. In the same way, for example, if I'm taking one loop I'm taking, that loop is repeating n times. I less than or equals to n and is a I plus plus. I plus plus. And here suppose we are writing like a x is equal to y plus z. X equals to y plus z. Now this one is taking how much time means what? It is a constant time, order of 1, but this loop is repeating n times. So it is executing n times. It is executing n times. Suppose if you write combinedly, outside I'm taking like one calculation a equal to b plus c, and next followed by we are writing that repeating the loop 1 to n times. 1 to n times. And inside we are doing another operation like x is equal to y plus z. As we know that it will take as a constant time, and it is taking n iterations. It is taking n iterations. Okay. Here the total value, suppose if you are taking this is a order of n plus is a constant time 1 is a n plus 1, but comparing to n iterations in the process of time complexity in searching, I mean, what in finding the time complexity, Compared to n iterations, one iteration is always negligible. So the final value of this one is order of n. This is actually, we can call it as a big O notation. It's actually called big O notation. This is the way we are finding the constant time we are finding. Right. So here, so in the same way, so whenever you are finding that value, suppose I'm taking here, nested loops we are taking. One loop we are repeating. One loop is outer loop is repeating n times. Outer loop is repeating n times. And inner loop also we are repeating n times. J equals to 1. J is less than or equal to n. J plus plus. Inside, some statement is executing. Is a statement is executing. So time complexity means what? Not a loop iteration, just how many times it is executed. This one is a n times is repeating, n times, and this one is a n times repeating, is a n times repeating. So that so total is a n square times, n square times it is repeating. Again, same story. For example, outside you have written one extra statement outside. Again, compared to n operations only, that is a one iteration is a negligible. Now is a n square also, it is a negligible. And this is what simply to say is a time complexity. Simply in expression evaluation, nothing but in execution, expression execution. Suppose I'm taking one expression like this, a into n square, a into n square plus b into n plus c. Suppose whenever you are giving the values like a equals to 100, b equals to 50, and like c is equals to 1, suppose you enter. Now, whenever we are giving that 100 into n square plus 50 into n, 50 into n plus c value, 1. Compared to this much, these many iterations, compared to these many iterations, we can make it negligible these many iterations. So simply to say that 100 into n square only we consider as a time complexity. Considered as a time complexity. Just only so based on the number of iterations or nothing but how many times that statement is getting executed. Based on that statement getting executed, we simply call it as a big O notation, or we can say that time complexity. Suppose I'm taking a loop like this. While loop I'm taking. While they have given n starting from n up to 1. Inside, what we are writing is based on the time complexity. N value, n is equals to, just I'm writing n minus 1. Nothing but n value is decreasing by 1. So 10 become 9, 9 become 8, 8 becomes 7, 7 become 6, and so on up to 1 is nothing but n means what? Every time 1 decrement means what? N times this loop is iterating. N times this loop is iterating. So how many times this code is executing is a big O of n. Sir, suppose I'm just writing n is equals to n minus 2. n minus 2, I'm taking nothing but suppose starts with a 10. 10 minus 2, 8. 8 minus 2, 6. 6 minus 2, 4. 4 minus 2, 2. 2 minus 2, 0. Only 5 times it is iterating. 5 times. So simply to say, it's a half times only. 10 become 5 is nothing but n by 2 is a n by 2. Like how many times it is iterating is important. So in the same way, suppose simply I'm just writing n is equal to n minus 20. So we can easily say that how many times means what is a big O of n by 20. Big O of n by 20. This is how it is iterating. Okay. So means what is a minus 1 is a minus 2 like minus 20. So big O of n, big O of n by 2, big O of n by 20. This is the one. So here, suppose if it is a linear search algorithm, if it is a linear search algorithm, when we can go with the linear search means what? When elements not in proper order, randomly elements are there. If elements are in order, we better go with the binary search operation only. Here it is. We go with that linear search. Linear search. There's so many elements are there. So many elements are there. 2, 5, 7, 1, 8, 6, 13, 10. Suppose values like this. Okay. Now in this one, so whenever we apply that linear search, I just want to search for the key. It is at the top location, top is means what in the starting location means what. So here it is, we are finding within one iteration only. But big O notation is not finding that nothing but algorithm efficiency. Whenever you are going to find out the time complexity, whenever we are taking the best time, nothing but efficient time, average time, and worst time. 3 cases we need to consider. But this is the best case. But big O is not that best case consideration. Right? Big O notation is finding that worst case consideration. Suppose if you are looking for that last element, how many iterations are required? So total n iterations required. Total n iterations required. So that is actually called big O notation. Worst case. Worst case time complexity. This is what? Worst case time complexity. So finding that is what we call a big O notation. In linear search algorithm, what is the time complexity of linear search algorithm means what? We can say that big O of n. Big O of n. For example, if it is a binary search, we know that binary search we can apply only when elements are in sorted order, either ascending or descending. When all the elements are in sorted order only, we can apply. Reason is what? Whenever it is finding the middle element, if that key element, if the key element is present in the left side array, it will move to left. If the key element is moving to the right side array, then it will fall into right side. Every time with the help of mid element, It will find out either it will go to that left side or it will go to that right side. So that is what a binary search algorithm. So how it happens and what is the time complexity? What is that time complexity? How can we find out? First, with a simple example, while until we find that, until we find that every time we make it half. Suppose n to 1, we are repeating. Every time we make it half and then moving to either left side or right side. Left side or right side. Like that we are moving. Like that we are moving. In general, suppose if you want to explain the time complexity, easy way, first I'll explain. Easy way. N is equals to, imagine size is a 128 I have taken. N by 2 means what? If you make it half, it will become 64. Again is a make it half is a 32. Is a make it half is a 16. Is a make it half is a 8. Is make it half is a 4. Is make it half is a 2. Is a make it half is a 1. So for how many iterations it reaches 1 means what? Exactly 7 iterations. Exactly how many iterations? 7 iterations is a 1. Okay. 7 iterations means what? Whenever you are using the word logarithm of 128 base 2, value is equals to 7. Is equals to 7. So that constant time, if anyone asks to find out, we can say that log of n is nothing but how many number of elements you have taken. So how much time it will take is this within a 7 iterations you will get. 7 iterations you will get. So simply to say, for example, first n by 2 power 1. N by 2 means what? N by 2 power 1. In the next iteration, what will happen? N by 2 power 2 is nothing but 4. N by 2, n by 4. Next, n by 8 is a 2 power 3. And so on. What it will become? N by 2 power k. N by 2 power k. It reaches this one. Constant time is what? N by 2 power k. So whenever we are writing that, n by 2 power k means what? The 2 power k, please send to the right side. Is that 2 power k will go to the right side. Okay. Then simply we are applying that. Just we are writing in reverse. 2 power k equal to n. Just apply logarithms both sides. Log 2 power k, 2 power k equal to log n. Log n. Okay, that k will come front. Here it is. Just simply we can say that log 2 base 2 value is a 1. That we know. So simply we can say that k equals to log n. Log n. So what is that constant time for this one? If anyone asks, what is that constant time for this one is what? Log n. The same thing we are using in a binary search. The same thing we are using in binary search. That's why simply we are saying that this is what log n times. Is a linear search means what? Big O of n. Is a binary search means what? Is a big O of log n. Big O of log n. That is the simple way we are understanding. And suppose if I'm taking this one, if I'm taking this one, is a while n is greater than 1, you can take, but only for explanation, only one iteration I am just reducing. Suppose n equals to, I just make it a square root. N become square root of n. N become square root of n. Simply. Square root means what? 1 by 2 power 1. 1 by 2 power 1. So if you are writing this, so 1 by, simply we are writing that n is a 2 power 1 again. 2 power 1. Like this, it will go up to 1 by, just like the previous example, k times it will do. K times 2 power k. 2 power k. But here it is, I am taking up to 2, na? Not 1, because to make it easy, just one iteration we decrease. One iteration. So here I am taking to 2. I am taking to 2. Right here it is this one, take it to the front, and by applying that log n. Easy. So here it is what? Just 1 by 2 power k, 1 by 2 power k. And anyway, we are applying that log. It's a log n. Right side is also, we are applying that log, because both sides we need to apply. Log 2 base 2 value become 1. And the 2 power k, I'll send to this one, or in the next line, I'll explain. For example, is a 2 power k, 2 power k. And whenever you apply this log n, that value log 2 base 2 value 1. Now take to the 2 power k to this right side. So log n equal to 2 power k. 2 power k. Again, apply both sides a log. Or first you can take it to the right side. 2 power k equal to log n. Log n. Again, apply both sides logarithm. Log 2 and k equal to log of log n. Again, logarithms both sides. Again, log 2 base 2 become 1. So that constant time k equal to log of log n. And this one, constant time, suppose if you want to understand, this is the case. This is the case. We are applying in this way. Only just with the help of formulas, we can easily write like this. In the previous one, what we have discussed, in the previous one, while n is greater than or equal to 1 or 1, simply we are writing n is equals to n by 2 na? N by 2. Decreasing order, we are dividing. So this is what just big O of log n. Same only in a forward. While I starts with 1 up to I less than or equal to n, simply I is equal to I is multiplied with I square, not square root, square is the same only. Is the same only. Is a by 2, and here it is a multiplied with the 2. This is a decreasing order and this is a increasing order. Decreasing order and it is an increasing order. That is the way. So based on this one, sometimes we are writing, suppose outer loop is repeating n times, I equal to 1, I less than or equals to n, I plus plus, I plus plus. For example, finding that like a perfect numbers within the range. Suppose we are taking, or suppose inside this, I have written this while loop. I have written this while loop. Up to n times we are repeating. Every time multiplied with a j. Directly I'm writing. See, for make you understand. Directly I'm writing j is less than or equal to n. J equal to j into j. Sorry, j into 2. Why I'm writing I into I is what? Suppose if I write make it multiplied with a 2. I just multiplied with a 2. Simply. Is a by 2 now? Is a by 2. This is very sorry. Into 2. Into 2. Is a by 2. So that it is a into 2. Suppose here it is 10 become 5 in the above program. Better we use 20. 20 become 10 become 5 become 2 become 1. In the down direction 1 become 2 into 2 become 4 into 4 become 8 into 8 become 16 like this. So into 2 we have to do. Sorry. That square root we discussed now. Square root. First before explaining this. Sorry. Before explaining this, I already explained this one. While n is up to 2, inside what we did? Inside what we did? N is equal to root n we discussed. Root n. It's a square. That is exactly equals to is what? While I is less than or equal to n. Sorry. N. Inside that I into I. I into I. Look at this. This is n by 2. This is I into 2. Is both are same. One is in decreasing order. One is in increasing order. This one is what? Is the same. One is a decreasing and one is increasing. It's a square root and it's a square opposite. We already discussed this. What is the time for this one? Just we go of log n. So this one also same. Every time square. We go of log n. Log n. Now this one we apply this first. This is n times and this is log n times. So for this one, here it is a simply we go of outer loop is a n times, inner loop is a log n times. The same code we are writing like this. For I equals to 1, I less than or equal to n, I plus plus. Sir, inner loop is also for loop only I'm taking. So okay, j equals to 1, j less than or equal to n, j equal to j into 2 I'm taking. J into 2 I'm taking. Both are same. This multiplication I'm writing here. So it is also we go of n log n. We go of n log n. This is the way we are just finding that one. So suppose if I place this here means what? N log again log n. N log again log n. Okay. So based on all these things, we are just finding that time complexity. And so one more thing, suppose if you just give names to this time complexity, names. Simply, the first one, we can simply call it as a constant time. We can call it as what? constant time. That is what? Big O of 1. I already told you that any single statement, any single statement inside any function, let us take x is equal to y plus z. That statement will take always a constant time. Always constant time it will take. That is, we can call it as constant time. Okay. That next one is we are taking linear time. We are taking what? Linear time. Simply to say linear search algorithm. Linear search. N times exactly if anything is repeating, loop repetition. I value starting from 1, I less than or equals to n, I plus plus. Inside that, if you write that statement, is a how many times it will execute means what? It's a linear times it will execute. Is a linear times it will execute. Next one, they will tell it's a logarithmic time. Logarithmic time. That is what big O of big O of log n we are taking is a logarithmic time. The best example is what? Is a binary search only. In a binary search, by taking that array, inside whatever that logic you are defining, that will execute that logarithmic time. That is also we have discussed. Is actually as a square loop inside the loop exactly if it is executing, we can call it as a quadratic time. Quadratic time. Simply order of n square we call. Order of n square. And you know that which one executes means what? Which one? Which one executes means is outer loop. N times it is repeating. And inside that for loop is n times it is repeating. N times it is repeating. Then, so this is actually called what? Is a quadratic time. Is a quadratic time. Is a sometimes already in the last class in a dynamic programming, we have seen that Fibonacci series through recursion. They will ask that is called exponential time. Exponential time means what? Exponential time means what? 2 power n is a 2 power n. That is a square times 2 power n times it is increasing. Because of that number of iterations, execution time always double with each increasing the input size. Double, double, double. Because I already told you that. Suppose if you pass Fibonacci of 5 consider. Fibonacci of 5 consider. So how it will calculate? First Fib of 5 plus Fib of 4 suppose consider. And again here it is calculating. Fib of 5 plus 4 means what? Again it will start what fib of 4 it will calculate. And fib of 3 it will calculate. 3. The same thing happened here also. Fib of 3 it will calculate. Fib of 3 and fib of 2 it will calculate. So whenever you are increasing the execution time always doubles with each increase in input size. If you just increase that input size only one time, that execution time double. Always execution time double. So mostly, suppose so many are there, but these are the main. Suppose if they ask, just tell me that constant time means example, linear time, logarithmic time, quadratic time, and exponential time. Okay. This is simply to say that time complexity explanation based on this one.